Alright, hi everyone. So this is my video tutorial for Codeforces in round 1106 division 2. So first, go to problem A. So in this problem, it tells you can, for any element in A, you can, do A minus 1. So you can do X minus 1 for that element. And you want to change A into B, and you can also shuffle the elements in A. Okay. So in this problem, when I first look at it, we know, so the elements in A, they can only decrease, right? So uh if there's any positioning A that's less than the positioning B, then it's not possible. For example, right here, you cannot make this 2 into this 3 because you can only subtract from this 2, so it can only go down. So it can go 1, 0, but it can never get to 3. So if that case happens, then we have to shuffle the array. When we shuffle the array, all we have to do is sort them, and our answer becomes C. And then for both values, we can just make a simple loop and find how many subtraction operations we need. So that is problem A. For problem B, it's a math problem. So here we have following condition. So first we want to try to simplify it, right? We have GCD, LCM, A, B, and LCM, BC is equal to GCD, AC, right? Well, first notice that there's two B's in here. And this is a LCM, and the GCD of that will definitely contain this B because both LCMs contain a factor of B. So we can simplify this to B times GCD, and now it's just GCD A, GCD AB, and GCD BC equals to GCD AC. Um, from this step to this step, we take out a B in this, and then the LCM here turns into GCD, and LCM here also turns into GCD. Now this can be simplified further. It's actually just B times GCD ABC equal to GCD AC. Now from this, I turn this into B will be equal to GCD AC divided by GCD ABC is actually just GCD of GCD AC and B. Now once we get to here, it becomes clear. B must be a divisor of GCD A and C. Because if it's a divisor, then this just turns into GCD AC divided by B. So basically, B will divide GCD of A and C, or in other words, B will divide A and C. So once we know B divides A and C, we can just do a simple loop for B from 1 to n, and then we calculate how many values work for A and C. Okay. Problem C. Problem C is a tree problem. So first, I have the vector pair parents. So they gave us the parents, and we want to find how many fields are there. Uh, so first I read in the input. So first, we make an adjacency list also, and then I look at this problem, and I look at the test case. So for test case 3, look, um, we have so first off, there's the single nodes, right? So we all know that, and then there's these two, and there's also these two. Now I look at the large test case over here, and I use the graph editor in CS Academy. So all you have to do is paste in the adjacency list here, and you can config, and then you can arrange as a tree. So it becomes really clear. Okay, now notice, currently there's 15. There's 15 nodes, right? So currently the answer is 15. And then for node 0, it can go 1. So we have D3, 2, 3, and 4. So we add 4 to our 15, so now we have 19. And then if we go to here, we have these two. So we add another one. So now it's at 20. And you go here, we can add 1, 2. So we add 2 more, so we get 22 as our answer. So that's how we got the answer of 22. So this led me to see if right now we have a node and it has at least 2 children, then we can find the answer for this node with the children. So basically what I mean is this. We start off with a DFS for the depths of nodes and the max depth in this node subtree, right? So starting off, max depth will equal to depth current, and then we loop over all of the children. The depth of the children will be equal to the current depth plus 1. And then after we DFS on this children, on this child, um, we can update our current max depth. Now, how does that help us? Notice here, right now we have this, right? We have 0. Um, we have current max depth over here is 4. So the current max depth over here is 2, 3, 4, and over here is 4, and over here is 1. Now from here we get 1, 2, 3, 4 different guilds. So we add 4. Now that notice that max depth is also 4. We have 1, 4, 4. So the maximum of those is 4. But also notice over here, once we get to node 2, we have 1, 2. So we added 2 to it, right? So that is also added 2. But when we get to 6, max depth is 2, but we only add 1 because node 14 is by itself. So basically what this means is uh, for every node, we take all of the max steps from its children, we can sort them, and we take the second largest and add it to our answer. That will always be valid because the second largest over here will always have another node with it. So it cannot be a single node by itself. So first we have, so over here we have answer, we have our DFS2. We start at 0. So we construct our D. So these are the max depth distances. We loop over all the children, we DFS on those, and then we do D dot pushback max def next. So we put all of the max def in this D. If it's a leaf or it only has one child, we can just do answer plus plus. So the answer only plus its current node. For example, right here, node 1, answer only plus is node 1, because the future guilds will be counted by node 2, its child. And if it's a leaf node, there's no more, so we only add 1 to it. Otherwise, you can just sort them and take the second largest. But no, the second largest right now, it's the max def, right? So for example, right here, it's 1, 2, 3, 4. And max def is 4. We also have 1, 2. So over here, we have 2. Max def here, the def here is 2. So we'll add 2 to this. And we'll also add 1 to the node. So we'll add 1 here. And then in the end, we can output our answer. Yeah, so this is problem C. Um, problem D, I think it's easier than problem C. Uh, so basically you have these layers, and then what it means is for every layer, every divisor of the current value has to be in a previous layer. For example, if the current number is, let's say, 10, right? And so the first layer can be 2. It can't be 2, 5 because uh 5 and 2 are co-prime. Yeah. So for every layer, the adjacent they have to be cannot be co-prime to each other. So 5 must go here, and then you can do 10 over here. But you cannot do 10 over here because 5 is not in one of the layers above it. Um, okay. So first I had an incorrect solution where I saw, for example, if you had um 36, then you have to do 2, and then 4, and then 3, and then 9. And then over here you can do 6, 12, 18, and then finally you'll do 36. So basically what I did was um This is factored, so it's 2 times 2 times 3 times 3. I did 2 over here, 2 to the 1, and then just 2 squared. And over here 3, and then 3 squared. So I did all the prime divisors. And then I found the ones that can be made by some of them combined. And then the final n is at the last place. Now there's a better way to do this actually. So it's like 2, 3, and then you have 4, 6, 9, and then 12, 18, and 36. So what this is, so look, notice over here, it's just a prime number, right? So first off, we make all the prime divisors, so all of them form their own layer, because we cannot do anything else other than that at the beginning. Then we find the ones that have power equal to 2. So the sum of the power is equal to 2. For example, 4 is 2 squared, so the sum is 2. 6 is 2 times 3, so 1 plus 1 is 2, and 9 is 3 squared. So we made them. So notice that all of them they can make a layer together. Now after that, it's the power of threes and the power of fours and so on. So what I noticed was the answer will just be the number of prime divisors minus 1 plus the total sum of the exponents. And this is true for everything. So first I have my factor. This is in my templates. I think you can also find on the cycle guide. Um, so I factor them. And then for first, the answer will be the number of prime divisor minus 1, right? Minus 1, plus the exponents. So the exponent over here will be in a second. So, and then we can just output our answer. Okay, yeah, so those are my solutions. I didn't manage to solve E during the contest, so I'll try to upsolve it later. But yeah, um, hopefully, since I'm first video explanation, hopefully everything is clear and I didn't pass over too many observations. So yeah, bye.